So if you want to make, just take an example here. If you want to make a micro mouse, you just have you should have a picture about that micro mouse in your mind. So how you want to make it? You should have a simple design. Like you might know about Fusion, right? You might be doing it in Makerspace, so you will do. You might have heard it. So there are designing softwares where you design like many designs you make, whichever is the best, then you implement your hardware on it. So design will be covered later in the workshop. You'll learn how to design, accurately depending on your requirements. So next, hardware and autonomy. First, we'll go to our hardware. I'd like to call Nishit. He's also from the hardware division. He'll tell you more about hardware.
So hello everyone, I'm Nishit from Hardware Division in Robotics Club. So first of all, I would like to start with sensors. So basically, sensors are devices that helps us to detect the physical change in environment, such as temperature, pressure, heat, sound, vibration, and all of that. So basically, there are many types of sensors like proximity sensors, image sensors, vision sensors, and temperature sensors, accelerometers, gyroscopes. So first, I would like to tell you about proximity sensors. So there are two types of proximity sensors, infrared and ultrasonic. And as the name suggests, it is used to measure the distance between the objects or detect the obstacles in the way of the robot. So here you can see a small diagram. So you can see a diagram over here. This is basically a ultrasonic sensor. So its basic working principle is like it has a transmitter. It emits an ultrasonic sound wave, which gets reflected by the object in front of the robot and is received by the receiver. So the ultrasonic sensor basically measures the time for the to and fro motion of the wave, and according to it, it calculates the distance. Now, gyroscope. So, gyroscope is used for maintaining the orientation of the robot. Basically, a self-balancing robot has an immense use of gyroscope. So, I would like to explain you how a gyroscope works. So, basically, it has a small wheel inside it. It is spinning, and you might have studied conservation of angular momentum in your JE and studies. So when a robot is tilted, the wheel will be tilted, and due to conservation of angular momentum, the spinning wheel will resist its change because when its axis changes, its direction of momentum changes, and we don't want that to happen because of conservation. So it exerts a resistive force that is measured by the gyroscope, and by that, a robot maintains its self-balance. Now, time of flight sensors, it works similarly as ultrasonic sensors. So I would like to ask you, like, what will be the difference between time of flight and ultrasonic sensors? The working principle is same.
So these are the ultrasonic sensors we are talking about. So just have a look.
So okay, I will explain you. Like time of flight sensors basically uses light. Now light is because of using light, we can measure distances more accurately by using time of flight sensors. Like distances up to millimeters can be measured by using time of flight sensors. Now regarding which sensor is better, it depends on our work environment. Like if you are working in an environment which is very dusty or which is very dark, so using light over there doesn't make any sense. We have to use sound. And if you are in an environment which is uh, humid, or there's a regular change in humidity and temperature, so the sound will get changed and the velocity of sound would change, and therefore ultrasonic sensor could not be used there. We have to use a time of flight sensor. Light is unaffected by that. Now, what are motors? So motors are basically devices which convert electrical energy into mechanical energy. I'll explain you the mechanism like how a motor works. So here you can see that there is a stator. This is the stationary part of the motor which contains the electromagnet. This is the rotor part which consists of an armature and an air gap. This thing basically rotates, and we have a commutator which basically, like it changes, it helps in changing the direction of current or maintaining the direction of current. The shaft is attached to the rotor. So there is a coil wounded around the what we say core, and then when a current is passed through the coil, there is a magnetic flux in stator as well as in rotor. Due to interaction between the magnetic flux of stator and rotor, it generates a force which helps in turning the rotor, and the shaft is connected to the rotor, so it also turns. Now the turning of shaft, it is used to perform the work on like turning the wheel, turning the blades of the fan, or turning the gears in machine. Then there are different types of motors like DC motors, AC motors, servo motors, and servo motors. So DC motors basically use DC source, DC current, and by changing, if you want to change the speed of the motor of the DC motor, we have to change its voltage. Like basically, in DC we change the voltage to change the speed of the motor. In AC motor, we basically change the frequency through VFD, like variable frequency device. We change the frequency to change the speed of the AC motor. Now, stepper motor helps in controlled rotation. It rotates in steps. It does not rotate like it does not give a continuous rotation. If you want step-by-step rotation, we use stepper motor. And servo motors, they are used for you know having a precise angular position, as it has a position sensor inside it. It it keeps a track of the position of the shaft. So, due to feedback mechanism, there is always the position stored in the servo motor, so it can help us.
So in this row, who has the two motors? So which is that motor as per whatever you wrote? Servo motor. And the other motor who has? Right. So you guys are listening. And this side, who has the motor? DC motor. Right. And which has played again?
So now we want to control our motors. We want to rotate our motors according to the, we want to control the direction and the speed of the motors. So we cannot do it directly. We have to use a motor driver. So motor driver helps us in, maintaining the speed and the direction of the motors. It basically does that through pulse width modulation, and that is basically done through changing the duty cycle. Duty cycle is a fraction of the time period in which the signal is on. And pulse width modulation helps us in measuring the power that is given to the motor. Like pulse width modulation does that. If you want to give less power, pulse width modulation will give less power. Like if you say duty cycle and if you say 50% duty cycle, so it means that 50% power will be given to the motors. And if you want to turn the motors at full speed, then it will be 100% duty cycle. So basically, pulse width modulation does that.
What do you guys think? If we directly power the motors using the battery, how can we control it? Is there any other method to control?
Potentiometer.
What?
Potentiometer.
Yeah. How will you do that?
By connecting it through the VCC to the VCC to the VCC to the battery and ground to the battery, and the middle goes directly to the motor, and the ground from the motor to the.
So basically, you are just dividing the voltage using
Yeah.
potentiometer.
Yeah.
Similar type of work this
There are
IC is
also
doing.
more than this. This is L293 and other one is L293D motor shield,
Yeah.
which comes to control at most 4 motors at the same time, and a sticker motor 2 at a time, and 2 servos at a time.
Yeah, there are different type of ICs which we can get. But the basic thing is that you can't control the speed of a motor without having a motor driver IC.
Motor, no.
Okay, so now I would like to call Tejas. He will explain microcontrollers.
So till now, who all understood whatever Nishit explained? थोड़ा सा समझोगे यार? इतने ही? सबको ही समझा? कोई नहीं, चलो समझा। अच्छा ठीक है। So whatever sensors, motors, motor drivers, all these components are there. But how do you think these are working in a sync, or how are you sure that they won't go running on their own? Like one sensor is sensing something, the motors are running on their own, the motor driver is giving some other output. So what is it that controls all of them and keeps them in the sync? What do you think? Have an answer. So, microcontrollers are basically the brains of a robot, if I say it in simple terms. Uh, uh, Microcontrollers basically think as if the robot is a human, just consider it as human. The human has a brain. The brain controls the hands, legs, ears, eyes, everything. The command goes somewhat from the brain only, right? So here also the robot has to get some commands from somewhere. So the microcontroller does that work. It gets the power from the battery, and then the microcontroller gives all the commands whatever we feed it into, and then gives it to the motors, sensors, cameras if we have them, gyroscopes, accelerometers. Microcontroller also collects data from these sensors. So the sensors are sensing something, like the ultrasonic sensor senses the distance you are using sound. Like he said, the time of flight sensor. The data from it, the microcontroller collects it and shows us on the monitor. We'll show you how it does later. Then motors. Microcontroller only motor driver can't be used to set the speed of the motor. We need a microcontroller to do that. The microcontroller would we will give a code to the microcontroller. The microcontroller will tell the motor driver that this is the speed which we want to move the motors in, and then the motors will move in that speed. So this is what a microcontroller does. One basic example of a microcontroller is the Arduino. Who all have heard about it? Yeah. Thank you. So Arduino is a kind of very famous, microcontroller. It develops microcontroller boards. So here we have two Arduinos. So as per this diagram, first we start with the pins, okay? From where we give commands to the sensors and so these are the digital pins. These give the signal in 0 and 1 format, binary. So these are the digital pins. This is the transmit pin. Like some devices require a transmitter and receiver pin, so these are used for that. This is the main microcontroller. This basically whole is the development board, and this is the microcontroller. So all this is required to make a perfect microcontroller which can control devices. Right? These are the analog pins. The range of what it gives depends on the microcontroller. This is the voltage pin where we will power the microcontroller. These are the ground pins. There are three ground pins. This is the 5-volt pin, like it will give 5 volts to any other device required. This is the 3.3 volt pin, and this is the reset pin, like reset the microcontroller board. This is the button board. Here we plug, there's basically this wire. This is used to connect the microcontroller to the laptop. So, as you know, the microcontroller needs to be coded. There has to be a code which is inserted in the board, right? So, we have to connect this microcontroller to the PC or laptop wherever we are coding it using this cable. So using that we put the code into the microcontroller. So now microprocessor and microcontroller. So what do you guys know about a microprocessor? Anyone?
Which operates all our devices.
And yes, माइक्रोप्रोसेसर कहाँ सुना हुआ है, कहाँ लगता है, कहाँ देखा होगा आपने कभी? Yes. So microprocessor basically वो पूरा it's microcontroller एक बहुत छोटा वाला है वो it can't control big devices like what you said laptops phones. It is just used for controlling some devices, some motors, some sensors, some cameras. That's it. A microprocessor is on a whole different level. It can control a PC, which is like a very powerful PC. Just one microprocessor can do that. Here are some differences. So the definition you are clear with. Microprocessor is a whole CPU which is used for extensive systems. Microcontroller is not that used, but it controls motors, sensors, all of that. Whatever is used in a robot. Right? Then we have the processing power. Again, you know the microprocessor has a very large processing power. Compared to that, microcontrollers don't have that much, or we also don't need that much power to control a robot. And if we need, then we can use multiple microcontrollers. Then in development, there are environments for the microprocessor. Even for microcontrollers, we have the environment. Like for Arduino, there is an Arduino IDE where we can code the Arduino. We'll tell you more about it. Then power consumption, microprocessors obviously take more power. Microcontrollers are designed so that they take less power and work efficiently. Then we have the memory. Microprocessor requires an extra memory to be attached to it, like an external memory. So your computers, PCs have some extra hard disk or memory attached to it, right? The microcontroller has it in its board. So the whatever all components you saw, except that small chip, right? That is everything. The RAM, whatever LEDs are there, all this is included in that board, which are there. Then examples. So here, this is a Raspberry Pi, which is a microprocessor on a development board. So I hope you guys can see it. No? Like, ये एक ही अपना passing. And I don't know, you all have it. That's a microprocessor. You guys understood the difference? थोड़ा बहुत, थोड़ा सा spelling का difference नहीं, पूरा.
What do you guys think? We use microprocessors more or microcontrollers in robotics? Okay. But I didn't tell the application. Robotics is a very big domain.
From the projects,
In which kind of projects we need microprocessor more than microcontroller? IoT. Oh,
If it's doing image processing.
yeah. For all the AI tasks, image processing, computer vision, any automation tasks, for all those things we need microprocessor. But only microprocessor can't do the work. Like if you have a robot which is doing like localizing itself or doing some computer vision tasks, image processing tasks, and you want to perform some tasks from that. Like in the Namaste bot, you saw that there is the bot is detecting the person and then doing Namaste. So for detecting a person for image processing, the microprocessor is being used. Then with that microprocessor, we are using a microcontroller also to control all the motion of the bot. So microprocessors and controllers are used like with each other, complementary. But for small tasks which doesn't include AS and all, we use microcontrollers, like which we can hard code it.
So the Namaste bot which we had, right, that uses one of these Raspberry Pi modules. That is how microprocessor we use in one of our projects. Some of our projects which are currently displayed. First of all, the micromouse. So in the micromouse we have used ultrasonic sensor. So you guys know what a micromouse is, right? No? थोड़ा सा idea? अच्छा, I tell you. So micromouse basically is a maze solver. Maze solve, you have solved mazes, right? In like on the back pages of your notebooks, you have those mazes. Very easy, simple to solve. But those are easy to solve for us, not for robots. So we have to tell the robot how to solve it. So a micromouse basically does that. It's a robot, a size of a mouse, like very small. These robots are very small. We code them and they solve a maze which is totally unknown to them. They find all the walls, all the openings on their own, and they'll reach to the destination on their own. So we also currently are working on a micro in that we have used an ultrasonic sensor to so that it can detect all the walls which are there in the maze. So it will, you know the working of an ultrasonic sensor, right? Anybody can try? Anyone? Ultrasonic sensor, it works on sound, basically echo or reflection unit. There are, you saw the 4 pins on the ultrasonic sensor, right? Anyone wants to name it? VCC? एक बचा. Right, claps. So the ultrasonic sensor has 4 pins: VCC, trigger, echo, and ground. VCC and ground, I am sure you know. VCC is to power it, and ground is to connect it to the ground. Then you have the trigger pin. Trigger pin basically tells the sensor to release a sound signal. So the sound signal is released. The sound signal will reflect back from the obstacle or object which is coming, which is in its way. The sound will come back. Then whenever it receives the signal back, the echo pin will send an signal to the microcontroller. Then the microcontroller will tell us that it has received the signal. It will calculate the time it took to receive the signal, and using the speed of sound and that time, it will calculate the distance. This is how our ultrasonic sensor works. Right? Then we use a gyroscope. So in a maze, the micromouse literally doesn't know where to go. For the micromouse, there is just a square. It doesn't know any path, whatever is there in that maze. So to keep its orientation stable, we thought of using a gyroscope so that it doesn't lose its orientation while finding its way in the maze. Next, the motors we use here are the N20 DC motors with encoders. So like these are very small motors. If you can see. So considering the size of a micromouse, these motors are very useful. Like these are very compact and they give a great speed which is required for a micromouse. Additional feature here is the encoder. Encoder is basically something which tells you how much the motor shaft has rotated. So using that, we calculate how much distance it has moved. So it is again an extra, precaution so that our micromouse doesn't lose its way. If it miscalculates the distance, then it might crash into the wall. Right? So we thought of using these motors. Then the microcontroller we are using, we generally use the STM32. So I guess we have passed 2 of them. Right? So the black one, the small one, is generally used. The white one, which this row has, that is a bigger development board. It has a greater processing power. It has more features. But micromouse doesn't require all those. And obviously, considering the size, we use the black pin. So that is called STM32 black pin. And the one which the white one is the STM32 Nucleo 64. So those are kind of same, but they have different functionality. Next, the motor driver. Here we are using a different motor driver, again considering the size, but it works. The basic function of it is the same. Currently I can't do it, but it's this one. You saw this size, right? This is 2U. There is this small motor driver which controls 2 motors and gives equivalent power to this motor driver. So next we have the power supply. Generally we use these batteries. These are LiPo batteries, lithium polymer batteries. It's 11.1 volt, I think. These batteries are generally because like they have a good capacity to run the whole micromouse for a good amount of runs. So these batteries we thought of using, and the chassis is basically the structure of the robot where we keep or assemble all the hardware and kind of the body of the robot. So that we have custom designed. Currently it's not there, but we are working on it. So this is our project. The code, like this works on an algorithm. Basically, I'll tell you a bit about the algorithm. Later, the autonomy team will tell you more about it. So an algorithm is basically the steps on which the micromouse will work. So to explain you in a bit, consider the maze as grids. It is divided into grids. So consider an 8 by 8 grid. There are 64 squares. The micromouse knows that it has to go to the center. It will start from the left corner, 1 square here, right? It will fill all the squares with numbers. depending on the proximity. So the squares ahead and right of it, it will give 1. Then again from 1, whichever it is the closest square, 2, 3, 4, like that it will go on and fill those mills. Now it doesn't know where the walls are, so it will follow the numbers and to the center. Whenever it encounters the walls, it will again reset the whole numbering. So except that block which has the wall, it will give numbers again following the same pattern, which is the closest 1, 1, 1, 2, 2, 2, like that. Doing that for the whole maze, it will see where the paths are, how to go to the center, and it will calculate the shortest one. This is the basic algorithm. The whole algorithm is way too complex, so I can't show it here. But this is how the algorithm works, and this is how our project will work. Next. Now, the gesture control card, Dishank will explain it.
Hello everyone, my name is Dushan and I was involved in this project, which is gesture control car. So you can see that many the components are given here, like the DC motors. So the important part and highlight of the project was the mechanism wheels. You can see over here. So the wheels are special because like the forces which are applied over here on the road, they are at 45-degree angle. They are not forward. So we can use these wheels to move our robot sideways, rotate right, etc. Okay. So as I explained that we used mechanism wheels here. Okay. So first of all, we wrote the code for the microcontroller. So we used an ESP8266 module. And the code basically included various functions for movements like rotate right, move sideways. And basically the ESP8266 module, it receives the commands from the laptop because the gestures are recognized on a laptop and these are sent to the microcontroller. As for how that is possible, we are basically sending the commands over the Wi-Fi network, and this is possible because we have used a Python library which is called Socket. So it enables like server client connections between the nodes. And so we use the MediaBike library, which is a machine learning library. So this helps us get landmark points of the hands. So basically our hands has many points, like this, and so on. So this MediaBike library gives us those points, and we can use like simple distance calculations to check if a particular finger is closed or not. So in the end, like the robot receives the commands and moves accordingly. So you can see this was a robot, and over here you can see that when the car is moving forward, how it is like applying the forces on the road. So you can see that over here, it detects the landmarks. And if there are any landmarks, it tries to recognize them. And in this line, you can see that here is the line where we send the command to the microcontroller. And here is like simple mathematics to determine if let's say a finger is closed, then it's 1. If it's not closed, then it's 0. And accordingly, we have determined like all are zeros. So this means stop. And like if all is 1, like this is forward, etc. Okay, thank you so much.
कोड किसको लगता है ये मेरे से नहीं होगा मतलब कोड हमसे होगा ही नहीं अरे किसी से भी मेरे को तो आता ही नहीं भाई तुम लोग बताओ
इसके पहले वाला देख के लग
लग रहा था
और
कोई नहीं, वो है ना वो 2 है वो ऐसे समझाएगा कि तुमको लगेगा कि ये कोड हमसे नहीं हो रहा था ये तो आपके बना देंगे देखना हो जाएगा सच्ची anyway so इसमें एक interesting part here is that these wheels which you talked about normally wheels का कितना degree of freedom है कितने direction में move कर सकते हो 2 front and back बाकी turn for the turn हम उसका angle change करें तो move होगा These wheels are special. These don't require us to change the angles. If they want to move forward, they'll go front and back. But अगर इन्हें sideways भी move करना है ना, they'll move, and these special rollers are there. You can see there are rollers on these wheels. Using those, it can move sideways also. So that is the specialty of these wheels. I got to know about this when I came into the club, and this was like something very new for me. ऐसा लगता है ना छोटे बच्चों को खिलाना मिल गया तो ऐसे कुछ हो जाता है। मेरे लिए ये था। Then similar, these components he explained, Dishak explained. Then the JC was designed by the team only. So usually the structure of the robot is designed by the team only. Like in their cases we get it ready. So that was it for this project. You might have seen this robot running right in orientation. Yes. So this is a basic code for an ultrasonic sensor. I'll tell you about it in a brief. So hardware team also needs to know about the code. So like the hardware team knows right what the sensor needs, what it will give, how to read it. We should know a bit coding. So it's not like you should know everything about it. A bit of it is in there. So I'll tell you what we need to know. So the pins, which the 4 pins we mentioned, 2 of them are the trigger and echo pin. So the 9 and 10 written there is what you might have seen the numbers here on this microcontroller. The digital pins 9 and 10. Right. Everybody has seen it, right? With the pin numbers. So we define the pin number there. The trigger pin is put in the 9th pin of this Arduino, which is PWM pin. Nishit explained what is PWM, pulse width modulation. So it gives a varying signal depending on the duty cycle, right? So trigger pin and echo pin we defined it 9 and 10. Next is it is a function. You guys know basic about coding, right? Functions and all. You might be studying it in a course. You have a C++ course, right? First, the communication. So the serial dot begin 9600. That value is basically at what rate it will get data, receive data, and send data. So that is 9600 bits per second. Then baud rate. Bauds, right? Bauds. Next, we set the trigger pin. So as I told you, the trigger pin will give the sound, transmit the sound. So that is the output. Echo pin will receive the signal after it's reflected. So this is it. We have to define these pin modes. Then this basically we are telling all this to the microcontroller, so it knows that what each pin of that sensor is doing. Next, the loop. So it will this whatever we write in this function will run into a loop. First, we are setting it to low, digital write pin, trigger pin to low. Then, as we set the trigger pin to high, the sensor will release sound signal for 10 seconds. There's a time we can set here. Delay is basically for what time you want to keep that process, whichever process you are running, for that amount of time. So the unit is basically in microseconds. You can give any amount of time here. Again, we make it high, it reduces the sound, trigger pin low, it stops the sound. Then the echo pin has received the reflected sound, so we read the data from it using the pulse in. So pulse, it has received the pulse in from echo pin, which is then set to high, so that the echo pin is activated, the microcontroller can take data from that echo pin. Next, the calculation, simple calculation, sound and distance. The time taken by it is t, which is given by the sensor, speed of sound we know, and by 2 because obviously the sound was reflected. Next, we have to, this is to print, like we also want to see right what distance it is giving. So serial prints, it will give the distance on a serial monitor. Serial monitor is basically an output screen for the microcontroller. So each ID has a serial monitor where you can see outputs from the microcontroller. So this gives that. And then again, it waits for a short period of time so that it is not too rushed. So all the values come in, and we can examine what values it is giving. So everybody understood? Any doubt? Anything?
Anyone who still feels that you can't code, you can't do this.
वर्कशॉप में वाला एक मोटर चला के जाना मोटर का इजी ये थोड़ा टफ समझा एवरीबॉडी अंडरस्टूड एनी
If
डाउट
you have any any doubt?
Any line, any. ये bracket में doubt है तो भी पूछ लो.
Pulsing
हाँ.
pulsing function क्या?
Pulse in अभी the trigger pin as I told you sends the sound signal. The echo pin receives it. So there is a pulse of sound. Pulse you might know, right? So there is a sound pulse. The echo pin receives it. Now for the microcontroller to know what it has received, that pin has to be activated here. The 10. We have set the echo pin 10, right? So that pin has to be set high. Then that pin will get whatever data the sensor pin has, the sensor or echo pin, and then it reads the data. So here we have used the long duration, the duration wala variable, right? That is the time. Echo pin gives the time, which the sound signal to. Right? Anybody else? It is basically the rate at which the data will come in and go out from the microcontroller to the devices which are being controlled by it. Any other doubt? Anything from the code? Fine? Nice. Good. So now this was all about hardware. Now we'll come to autonomy. Whatever this code was, I can't explain it much better, but the autonomy team will, I hope, do a great job in explaining it. So let's welcome them. A round of applause.
अभी तक किसी को कोई भी डाउट्स है? अभी हमने एक कोड का एग्जांपल देखा है, हाउ डू यू कोड अल्ट्रासोनिक सेंसर. Similar type of question we have asked in problem statement for induction. If you have any doubts, you can ask right now.
So, hello everyone. So, first of all, I am happy to see so many people here enthusiastic for robotics. So, how many of you already have an idea what autonomy might mean? Anyone who wants to give a guess? You might have seen autonomous cars, heard about autonomous robots right now, industrial robots which use the concept of autonomy. Yes?
Independent.
Independent. Independent from what?
External human.
Yes, very good. Anything else you want to say? Okay, so let's move on. So, what is autonomy? Autonomy means that you operate a robot, and with the help of that robot, you try to do tasks which before needed human intervention. Now, the robot can replace that person, and that task can be done without any human intervention. The invention of this autonomy in robotics came from the idea of industrial progress. So basically, earlier in industries, what used to happen, the simple task of pick and place and something very simple, very repetitive, humans would have to do that all the day long, and that would just lead to lack, a waste of resources. So to replace that, autonomy took the place of such repetitive tasks, and now those tasks are being done without human intervention. So basically, autonomy uses the sensors data. So it all starts from sensors, which you also heard from Nishit. So we use that sensor data. Then, with the data, we interpret it and try to understand the environment around the robot. That part is called perception. And after perception comes localization. What is localization? The robot then understands its current position and its current state. That process is called localization. Then comes mapping. What is mapping? So you have the sensor data, you know where you are, but you need to create a map of the whole environment to judge that what boundaries are near you, what obstacles are near you, and what free spaces you have to move. So that part comes under the process of mapping. And then you have path planning. Path planning means you have an initial point and final point. Now you want to go from that initial to final. So how do you path a plan to go from initial to final? That part comes under path planning. Next. So Namaste bot you all might have seen it in the exhibition, right? So here's a basic code flow of how we used autonomy in Namaste bot. So first of all, the main part of Namaste bot was that it has to detect the face of the person. To detect the face, we use USB cameras. Now we wrote a code that how USB cameras can be used as a webcam. That part was our first step. Later we come to the part of face detection using Hall cascade algorithms. Now there are various algorithms, there are various libraries for computer vision, for image detection and processing. So you will learn them further. Then the third step comes in, which is rotating the servo motors so that the Namaste bot can do the action of Namaste as soon as it detects a face. For that, we use RPi, which is a microcontroller. So in RPi 4, we wrote a code which will allow us to use the servo motors, and then we can use the servo motors to finally result into a Namaste action. Now this gesture control car already Dishant told you. So now, like we saw here, the sensor data, it helps us to do the perception part, then it helps us to do the localization part. Now I would like to show you a video of how mapping is done. So we have a video here of mapping with Turtlebot. Now what is Turtlebot? So in robotics, you will primarily use a operating system called robotics operating system, which is ROS. Now in ROS, we have a kit for open source access of a bot, which we can use to for which we do not actually need a hardware of robot, which we can use to create algorithms to test our algorithms or any process in online through simulations. So here, for example, what mapping does is, let's say this is the turtle bot you have. It will use its sensors to sense the data or to sense the environment around it. That data comes from the sensor, so this is the sensor data. After seeing its environment and percepting it, it will look for its localization, that where it is actually right now. And then we can move it around and form maps like this. So here's a video which will show you how mapping is actually done through Turtlebot and ROS. So here's this Turtlebot. Hello. Here's this Turtlebot which is moving around. We are moving this Turtlebot with Telio node, and I'll tell you more about this later. And as it is moving, you will be able to see a map being created here. So anyone would like to guess that which sensor is being used here by the Turtlebot to map this area? You just now heard about proximity sensors and image sensor like camera. Do you think any one of these sensors is being used or some other sensor? No. Yes, anyone answered it? LiDAR, yes. So LiDAR is is a sensor which uses remote sensing method. So would you like to tell how LiDAR works if you know? Yes, so LiDAR, the full form for LiDAR is light detection and ranging. So what it does is, it spreads these lasers across itself, and then whenever it comes in contact, the lasers come in contact with an object, it gets a notification kind of thing. It gets a message that, okay, there is an object, there is an obstacle at this distance. So that way, you will be able to judge which places are occupied and which places are free spaces to move. Next slide. So now this is the map we got. So in this map, the black lines you see, these are the boundaries or these are the places which are occupied. The robot cannot move here. And the white spaces, these are the unoccupied spaces. So what happens after mapping is done? After we get this map, we will import this map in any visualization software that we want. Further, this map will be converted to an occupancy grid where 0 stands for the free spaces available and 1 stands for the occupied spaces. And then, after the occupancy grid is available to us, we can use the path planning algorithms to trace our way from initial point to the final point using waypoints or using different algorithms I'll tell you later. and the sensor we use here is LiDAR sensor. So now let's do an activity. Can all of you open your laptops?
I just have a quick question. What do you think ROS is? Do you run it on Windows or it's a different operating system? Okay. So instead of Windows, I'll use ROS in my computer, right? This is what you want to say, or there is some dependency for ROS. How many of you are familiar with Linux? So ROS is run on Linux. We basically use Linux as our primary operating system. Then ROS is a sub operating system which is only needed only for the robotics task. And one question you all have, like you might have, why do we need ROS? Like we can make a workspace in Python and then we can run multiple files for running multiple sensor and all. Then why do we need ROS? Any guess? Having? Yeah. For syncing everything together, we use ROS. So you have one file, be it Python file, be it C++ file. I think they told something about, they took a name Node. And then they told like they'll tell it later. Node is nothing, but it's a file. Be
So can you all see this page as you open the construct.ai? Right? Now you have to log in here using your institute email ID.
Hello. Should use IIT Wi-Fi network for better connection, and also don't use Samsung AI is the concept of. Yeah, okay. Please refer, okay.
How many processes? So, how many of you have successfully logged in? Are you facing network issue here, internet issues?
Connect to IITI network.
Okay, those who have not made account already, please sign up. I had my account already, so that's the reason I logged in. Sign up using our institute mail ID. For those for those who have logged in, you can explore the interface here. What all things are there? Okay, how many are still facing issue with logins? Okay, since the number is less, I would request you guys to stay with me here, and I'll also show a video in the end for those who could not log in right now. So let's move ahead. You can see these tabs in your interface, right? Now you have to go to My Rostex. Rostex is basically your project here in ROS in the website of the construct. Now you have to create a new Rostex. Click on Create a new Rostex. So now what you see here are ROS distributions. So what are ROS distributions? So ROS updates its distributions almost very frequently, like almost every year there is a new distribution dropping in. So this you can say that if iron was the old distribution, Humble is the new updated distribution, and then we have dialectic, and there are many distributions which have been previous to iron as well. So for now, we will use Humble distribution since it is the most stable one as for this time period. Click on Humble. Make sure you click on Humble only, not any other distribution. Then proceed to I will create mine. Now you can name it anything that you want. Have you all named your project? Then click on create. Cool. So now you have to click on run to enter into the ROS development space. So everyone's notebook is loaded. So scan this QR because this is what we will follow through the process. Open this in another tab in your laptop. So now what we will do is, what we are going to do, let me brief you. We will, like just you saw how turtlebot was moving around in the space and we were getting a map. So how was the turtlebot moving? We will learn that. We will launch a turtlebot here. We will move it throughout our environment through teleop, and that's how that will be done. I'll tell you the code for that. So now you have to go to this section. Huh.
Okay, so I think many of you has named their project. After naming your project, you should click on the green button, run. Are you all following us? Okay. Is there anyone who is getting some trouble right now? Okay, bye.
So everyone has scanned the QR, I guess. So once you enter the notebook, do we have anyone who has not entered their notebook yet? Anyone who needs help? Tejas? Okay, so for the rest of you, you have to click on web shell. This opens a web shell where you will be writing your code. This is the terminal where you will type your code, and when you hit enter, it will run and you will see your turtle bot, your simulation in the other window. So everyone has scanned the QR, right? So when you open this, you will get this window. Now this tells you all the codes that you have to, all the codes along with their significance that you have to put into your terminal to see your simulation of turtle sim. So first of all, copy this code. What does this code mean? ROS2 is our operating system. This code is saying that you have to run the ROS2 turtlesim node. Now, what are node? As you just heard, nodes are created through which communication is established in ROS. So once you create turtlesim node, there is a communication passage open where you can now send your messages, send your topics, and you can see them running in the simulation. So first of all, we'll copy this and paste this in the terminal. So this is the turtle bot that we got after running that code. I'll show you the code once again. This was the code that we applied here, and that's the output that we got. So a node was established here to start the simulation of turtle bot. Has everyone executed this code?
Are you guys aware about the concept of encapsulation? You have a capsule, you just can see what's there from outside, but inside you can't see anything. So you ran a command here which is ROS to run turtlesim not. You don't know what's happening, but something open and you can just spawn. So that is encapsulation. This command is telling you that there is a package named turtlesim which has all the files for this window, for spawning and everything. And in that package there is a file named turtlesim node which you are running through ROS2. So everything about the turtle sim and everything you'll get in that package, which is named as turtle sim.
Can we go ahead? I think every one of you can execute this code. Okay. So now what's the next step? Now we will once look into what topics we have published. What is the topic list? As in, when we executed this code and we installed this package and this node, what all topics we got inbuilt with the package. So from this website, you can see ROS2 topic list. Copy that and paste it again in the web shell terminal. I would suggest to use a new terminal here. So we can see 5 topics in the list here. So what are these topics? So when I say that we have nodes, and what do nodes do? They communicate with each other in ROS. So one node sends a message, other node takes the message and interprets it. So the message that you are conveying, that is referred to the topic here. So moving ahead, let's see how this robot would move if you would like to move it around. Again, I'm opening a new terminal in web shell. Go to the website and here you will find a code. Copy this and paste it. So now what this code tells us? This tells us that we are running another node here in the package Telio Twist Keyboard. The node's name is Telio Twist Keyboard again. And under which what we are trying to control, we will control the command velocity. The turtle was velocity, its direction, and we want to move it around, right? So everything from its linear velocity to angular velocity to its direction, everything we can control through the keyboard using Telio Twist Keyboard. So once we are here, okay. So can every one of you please leave your systems for now and focus here for a bit. So here you can see some letters. Then there are more letters. and then you can see the speed and turn. What do these letters convey? So here, these letters are the alphabets from your keyboard, the keys from your keyboard, which you can use to control the robot, the turtle bot, and move it around in the environment. So it helps you to go in a 90-degree anti-clockwise direction. It helps you to go forward. It helps you to go into 90-degree clockwise direction. And similarly, you will also figure out that J is for anti-clockwise circle. L is for clockwise rotation of circle. K is to stop the motion. And further, similarly, M and the brackets you see, those are for backward direction motion. And these letters that you see, W, X, Q, Z, these are for increasing or decreasing the speeds. So now let's move our robot around. Can you see it's moving? Wait, I'll shift this a bit above. Can you see it's moving there? As I press the key I, I'm pressing the key I and it's moving in the forward direction. Now when I press U, it will move 90 degrees to the anti-clockwise direction, and when I press I again, it will move ahead. So this is how I am controlling the motion of the bot through my keyboard. Now similarly, you can press M and it will go in the backward direction. You can press L and it will start at its position. It will rotate in clockwise or anti-clockwise direction, or depending on what you press, J or L. And if you want to increase its speed, you have these letters here. So if I press W and then I move the bot ahead, you will be able to see that its speed will increase. So you can play with this around. How many of you are able to execute this? Okay, so for the rest of you who are not able to do it right now because of internet issues or something, I also have a video where I have explained this. You can see that video and understand it. So for those who could not do it here, you can still use the follow through code which I have sent through the website, the QR you scan, and try it at your rooms. And let us know if you want to explore more. The induction task will also be somewhere related to all these things. So I hope you'll enjoy doing all of this.
One question I have for all of you. Why do you think that we made you do this? There will be something we might have thought something in our mind. That's why we took up this and gave you this to do. No. So when you are working on any project, any robot you have, will you just buy the components and make it like run like manually, or you just code it and directly will make it run? No. You need some simulations. Like design people need some analysis and all. You need some simulation for autonomy also. Like the code which you designed, is it working properly or not? If it is not working, then there is no damage in software, right? But if you are working on hardware, what if you damage your hardware? You can't buy another one. So that's why we use these type of software for simulation purpose. And then once our work is done, or in between also, we can implement it on hardware.
So now I would like to introduce you to one more thing, which is RQT graph. So whatever I said that we have node, we have these many topics here, and a node sends a message, the other node receives the message. How can I show that to you through a graph? Let's see it. You can open another terminal and write there RQT graph. So the graph you see here, I'll zoom it. This is the same graph. So what does this graph mean? So this is a node, Telio twist keyboard, which we published, right? Publishing a node means setting a node, and this node will start sending messages. And this node here, total sim node, which also we created initially. So this node is the publisher node, or subscriber node, I'm sorry. So Telio twist keyboard, this is the publisher node, and turtle sim keyboard, this is the subscriber node. Publisher node sends the message. What is the message? This is the topic that you can see in between. Total one command width, which is command velocity. So this node publishes the message and total the node subscribe to it and receives the message. And the message is the topic that you see in between total one command velocity. So this is a very basic, very simple RQT graph. Later when you work on real life projects or when you make bigger projects here, you will see complex RQT graphs which make it easier for you to understand how many nodes you are working on and what all topics you are using in the system. Now I would like to call Vidansh to present the next portion of what autonomy serves.
So, good morning all. If someone is sleeping, so can everyone see what's the heading right now? Okay. So the label itself can describe it. Like we are providing computer the vision power. Now computer can see what we are seeing right now, or maybe more. How can a computer see? Anyone has any clue? Camera. Camera means optical wavelength. LiDAR. So LiDAR operates on different wavelengths. So maybe computer can see more than what we can see. Is there any other thing that helps computer to see what is around? I think one of the thing is distributed among you. Sonar, ultrasonics. What computer need is just an array of numbers so that it can see what's around. It can get data what's around. Right now, let us jump on what is optical sensors, like how we sense the optical wavelength that we are doing right now. Whatever computer uses, we have a library, OpenCV2, OpenCV. Like anyone have heard about it? OpenCV? Yeah, you want to tell about it? Okay. Anyone else? That's it. Yeah, of course, it's a Python library, and it is specially made for computers to get the data correctly so that it can interpret and see. And also, it's easy for us to handle the data. There are other libraries too, but this is more dedicated one. The another thing, if computer is seeing something, it's not like that the same thing computer is seeing we can see and interpret. Like that's why Python, C++ and languages are there. They are intermediate between us. So the same thing happens. What computer sees, we visualize it on monitor, like the way we are doing right now. Monitor uses a basic unit. Can you name it?
Pixel.
Yeah. So pixels. In short, picture element. It's the smallest thing you can see. Smallest square right now I can see here is a pixel. Do you know what pixel is made of?
RGB.
Yeah, RGB. RGBs are LEDs.
Basic color.
Yeah. So full form.
Red, green, blue.
Is there any other type instead of
Grayscale.
RGB?
Grayscale.
Grayscale. Okay. Okay. So all these names comes under this heading, that is color space. You have given an array. You know what is an array? Okay. Now, since many of you know about array, the same thing we just feed it to a computer. But what if we don't tell what the number of array represents? For RGB, the first value represents red, the second value green, and the third value blue. I'll show you how. And what if the color space is reversed? BGR. The complete negative thing you can see maybe. The picture you are seeing right now, the negative will come if the color spaces are not defined. So these three things are necessary. Now also, how does this red, green and blue make all the combinations of color? Have you read about interference? Yeah, the spinning wheel of the rainbow color wheel, you spin it and it becomes white. That's the same thing that what happens here while we just change the values, different values from of R, G, and B. The values range from 0 to 255 in our case when we are using Arduino ID or some simple general IDs. And these values, specific values are for specific colors. So if you want blue in RGB, you just give value 00255. You'll get the blue. I hope so. You understand? So I have an activity for you. Did you get what is it? It's a simple thing. And now we have another software for you. Have you ever heard of Tinkercad? Anyone use? Oh, many of you. Anyone wants to say anything about Tinkercad? Like, where did you use it? Electronics workshop. Nice. Okay. Anyone wants to introduce what is Tinkercad? Yeah. Stand up, please. No one? Huh? Yeah. So I would request you to please scan this QR if you can. Like, okay, I'll share it on WhatsApp also. इसी screen पे देखो. चलो Tinkercad है. करना पड़ेगा. मैंने मेरे उसमें प्रोजेक्ट डाल रखा है क्यूआर कोड में. नहीं अकाउंट में है ना प्रोजेक्ट. हाँ तेरा आईडी पे है ना प्रोजेक्ट. ओके वो तेरा आईडी पे बना है. हाँ तेरी आईडी पे बना है. Whoever is not logged in, just see the login.
Everybody logged in? Are you facing any issues, anyone?
Yeah, anyone? Network issues? Okay. Whoever doesn't have an account, just sign up using your institute email. You will see this dashboard. Maybe, and if you have followed the QR code, maybe you have got something else. Who's followed the QR code? Okay. You got a project in front of you, maybe. Wait. मी एक बार ट्राई करता हूँ Whoever has not scanned the QR code, just scan it.
तो का नहीं हो रहा वो लिंक से जा
लिंक तो भैया
लिंक भेजा है
भेजा है? हाँ
तो वाले
मैं तो वही सब फर्स्ट वाला है ना वही रुक वही इनको वही खुलवाएंगे हाँ खोल दो भेज रहा हूँ मतलब लोड हो रहा है हाँ डिज़ाइन के लिए भेजिए भेज रहा हूँ
लगा के समझेंगे टाइप यार एक बार अपने से ओपन करके भी देखना खुल रहा है कि नहीं
Everybody check the robotics interest group. There is the link of the project. So using that you can.
क्यूआर में प्रोजेक्ट क्यूआर में टिंकर कैड था
क्यूआर में प्रोजेक्ट था
क्यूआर में प्रोजेक्ट था
हाँ यार अभी तक नहीं लोड ही
हो रहा है वो लोड हो रहा है
हाँ चेक किया था didn't no
ये प्रोजेक्ट लिंक है ना
you should see this. Is there anyone who is not in robotics interest club group? No, right? Robotics interest group. Everyone is there. So you have got a link And then I'll get the basic. Tell me if you are seeing this type of screen. You? Okay, fine. Okay. I think people are. Okay, everyone is following up. Huh. For the people who are playing with this, कोई मस्ती नहीं करेगा उसको बनने दो उसके बाद मस्ती करना let it come, let it be complete हो जाने दो फिर उसके बाद उसमें जो जो ऐड करना है
For those who are not in robotics interest group, the link has also been put on IIT Indore 2728 group. You can check it there.
बताऊंगा जितना लोगों ने ये हाँ मैं चाह रहा था कि अलग अलग कंपोनेंट नहीं है सबको एक साथ नहीं मिल जाए कंपोनेंट और वो ऐसा कोलैबोरेटिव निकला या वो क्या है ना आई डोंट वांट टू डायरेक्ट इनपुट कर okay everyone is up to the page here which is not seen like that because everyone is playing around so what you can do
Have you ever seen breadboards? Okay, good. So uh, who all have seen breadboard in their life once, at least once? Okay, never. So some of our friends don't know about breadboard. Please, can you say something about where did you see that first?
Eighth grade. In school.
Okay, so can you tell me something about this? How does it work?
Basically, they are connected together.
Yeah.
Horizontal direction, the voltage is same in the in between the two, and in the extremities top and bottom, it is horizontally.
Yeah, as one of our attendees said, that the vertical columns you can see in this place, they are all connected together, and just at the extreme ends you can see this line. They are they all are just connected in horizontal line. So if you connect something here, the whole row is connected to that column. So everyone has imported these three things, I guess. Is it? Yeah. So now we have a sensor. We can sense the things. But how do we see the results? The main thing, visualization. Yeah, we have to use something like an actuator which can turn our robotic arm, fingers. So we need a servo. I think none of you were sleeping while Tejas Bhaiya have said about servo. Nishit Bhaiya also. Sorry. Import servo. Imported. Nice. Now we have an actuator, we have a sensor. What do we else need? Yeah, I got a. You can search RD. Yeah, everyone on the page? Huh. So now we are going to make connections. A basic control, if someone has not a good introduction about Tinkercad, we can rotate it with R. You can select it just clicking on it, and you can drag and drop it at any place on the breadboard and it will connect it to it. We have to connect the resistor end to one of the terminal of our flex sensors. Now, the point where you connected it, this will provide us the data. We'll connect this to our Arduino later. Now, we need to ground the resistor. So we'll connect this to ground on the breadboard. You can see this negative line. We are going to connect this with Arduino's ground. You know what Arduino is, huh?
If somebody doesn't know, then maybe.
Yeah. You know what color code we use generally for ground or fire? Black. The another end of flex sensors is connected to the VCC, 5 volts. We'll connect it to the positive end of breadboard, which will be later connected to 5 volts of Arduino. Acha, So you have got Arduino in your hands, is it? Right? Okay, fine. No.
You all saw the Arduino, right? So from where will we get that 5 volt pins? This. From where will we get it? Who all know there is an Arduino 5 volt pin in that board? Where is it? Yes. 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 There. Right?
So connected.
This one we'll get the 5 volt.
Easy part. I think everyone is late talking Tom. You have to connect the things, connect the dots, connect 5 volts to the 5 volt as we have discussed. The whole row is connected with the same component. So we have to connect this with 5 volt. We have connected it with this row or column, whatever you say. This whole row has same connection. Now you can directly provide it connection on any of the nodes to 5 volts. Now, where does the ground go? Can you see ground? I think there are many. Which one should we use? Is there any priority order or something? Okay. So according to your favoritism, you can click on any ground and just connect it on any dot since we have connected it to the same row. You can see all the dots are connected. When everyone is done this, give me a thumbs up. Okay, very few thumbs up. Double thumbs up. Thanks.
बाकियों का नहीं हुआ?
Everybody here? Completed? Done? Yeah, okay. We are moving forward. Now we want a data signal. So as I already told you, the point where our resistor and the other end of flex sensor is located, we have to connect it to any of the digital pins or any of the pin of Arduino. So again, according to your favoritism, choose any of it. Hana for a reason. Connect it. Okay, now we have connected our Arduino with the sensor. Okay, as I told you, the resistor and the flex sensor, where they both meet, the common point of that will go to any of the digital pin. I have chosen 7 here. Fine. Now our Arduino knows what's going on around. We are moving the flex sensor. This flex sensor is in our glove. Our glove will move with our fingers and the flex sensor will bend according to it, which will give the signal. It can change. See, sensors are usually resistive or capacitive. So for now, think, assume that it is capacitive sensor. So if you will change the angle of flex sensors, it will change the capacitance value, which will be calculated by Arduino, and according to that, we'll calculate the angle. Now connect the actuator, that is our servo. You can see there are two label around it: ground, power, and signal. Signal goes to one of the digital pin of Arduino. I use the 6D6.
So this pin has to be a PWM pin.
guess why it has to be a PWM pin? Why specifically a PWM pin? Anyone? It can be a normal binary pin, right? Any of the 7, 8, but why specifically a PWM pin? Any guesses? So this servo motor will move as per the input we are giving it, right? So if you want it to turn in 5 degrees, it will turn 5 degrees, 10 degrees, 20 degrees. So it is custom. PWM pin, as Nishi had mentioned, it is a duty cycle. So as per the duty cycle, it will give the pulse width modulation, right? So that's why a PWM pin is needed. If you give a normal digital pin, it will go high and low. That's it. So max and low in the least time. There is no control. We don't have a control of the circuit, right? So that's why specifically a PWM pin is used. Servo needs a continuous signal. That's why PWM pin is needed. Otherwise, just high and low is for an LED only. Like you can just turn it on and turn it off, but we need our servo to turn at particular angles. Now connect the power pin to 5 volts. Again the same thing. 5 volts is connected to this column, and the whole column has the same connection. So we can provide it at any node. Now take the ground pin of servo and connect it to the yeah, that's it for the hardware. Now comes autonomy. Now everybody here, सबका connection हो गया? Yeah, that's easy. Is it? Not easy, I guess. Click on the code, click on the text, and continue. You will see a code. The code right now you are seeing is of no use. You can just erase the content inside the function of setup and loop. We'll need them.
When Tejas was explaining one code of ultrasonic sensor, you also that there were setup and loop function. So whenever you are like for any hardware to work, first what do you want? You want to set up a microcontroller, right? Which you gave the signal, but how does the microcontroller know to which pin it has to give the signal? So first step comes the setup, then comes the loop. Why loop? Like when I'm doing some work, one function should be kept on like running in loop to perform a task, right? That's why these two functions you got by default when you went to the code. So whatever setup you want to do, you'll do it in the setup function. Then in the loop you can write all the code which you have to make run in loop, or you can make other functions for performing a task and then call that function inside the loop.
Yeah, all ready for the code. We are going to use C++ language right now. The code previously was in Python. Now Python is a basic language for us. Like it's very easy to understand for humans as well as for machines. So C++ is kind of easier for machines, but not for us, just because of various restrictions and framework. So next.
Text here. C++ R.
Now I would request you all to scan this QR code if you don't want to write every bit of code. That's a text, so you might not get any link. Okay, wait. Do you want to write code from scratch? Yeah, let's vote. The vote for the people who want to do it from scratch.
इसको कोड नहीं
हाँ, इसको कोड नहीं करना.
बेचारे ऑटोनॉमी वालों ने इतना मेहनत किया.
Very pitiful.
अरे पता है तुम लोग घूम लेंगे इस फाइन इधर मिल जाएगा. थोड़ा ही है, छोटा सा कोड. ठीक है ना, चलेगा ना? If you code from scratch, it's fine, right?
Yes.
So first of all, we have to include a library for turning our servo. Anyone who are learning right now C++? Everyone now? So how do we include library? Yeah, of course. Hashtag include IO string के जगह पे use servo. Yeah, in the previous version of C++, we used to write .h. We have to write it right here. It works on the previous versions. Have you read about classes, class and object? Yeah, you will get to know about classes and objects. I'm not going in detail, but this library has a particular class, and like ours, there are particular members. So we have to define a name of member. The class name is servo. Okay, anyone wants to go for dinner? I think if you want to do it in जल्दी करना है तो मैंने QR कोड दिया था. You already have text. You can do it. I'll explain it directly. Okay. You can copy paste it unless till then I'll explain the code. What is it? So yeah, we have a class like 1DC105. We have a servo class, and now we have to define one of the name. So we have a name servo. Quite short, but it will help us. Now we have to set up. As Bhavnath told us that every setup in our Arduino code should be inside void setup. Terms and conditions apply. Like sometimes you have to define some things which are need to be rigorously called, but that's another case. So we have defined pin mode. It will define the pins we are using right now. A0.
इसको 7 में कर दिया था ना, 7 में कर नहीं ठीक है, इसको A0 में कर देता है. Whichever analog pin you have connected, right? Just write that pin number over here. So if you have chosen A1, A2, A3, whatever it is, just write that wherever the A0 is, right?
The data plane of flex sensors, it is better to connect it on analog pin because the data is coming continuously. And to read it continuously, we use the analog pins. We have connected it to A2, so we are doing pin mode A2 input. Now we will attach our servo on 0. No, we have attached our servo on 5th. So we will change the 0 to 5. Yeah.
हाँ वो जो 7 पे
जो 7 पे किया था वो अपने A2 पे रख दिया. The data pin.
the data bit for which we are correcting it. Analog.
This is the minimum and maximum value we are going to use for servo. So take it 500. Now we'll run a loop in which we'll check what is there. It must be analog. So we'll check what is there in the analog pin A2. The values I have checked, they are from minimum 6 and maximum 33. So there are sometimes cases where the values are from thousands to 10,000, and we want the value to be 1 to 0. So we will use the function map. It will map the value 6 to 33 in the interval 0 and 180. So we need the angle 0 and 180. We have the signals as 6 and 33, 6 minimum and 33 maximum. That's the thing. While using serial monitor, if you have heard about this, hardware team has told you. The serial monitor, I printed all the values of the flex sensors, the minimum and maximum value. That came out to be 6 and 33. We map it to 0 and 180. And now we put it in the map function. And we'll write this on servo. So the servo will move according to it. And then we'll add a delay of 10 seconds, 10 milliseconds. The delay function works in milliseconds, so this is 10 milliseconds. This is for smooth simulation of our gigabyte. So,
Guys, we'll be winding up in more 10 to 15 minutes. So just hold your seats and just complete this experiment.
yeah, we have some surprises planned for you.
Huh.
So the person who stays here gets the benefit.
आधा मैच का मिलेगा हम कुछ नहीं है सरप्राइज है.
So that's it for the code. I think it's not heavy enough. Yeah, if you have seen some difference in Python and C++ are this main semicolons. You don't have to close every line with a semicolon in Python, but you have to in C++. There are many differences, but the main difference you can see right now. Now we'll try to run the code.
Also make sure that you have an object named SRBO and you are using the same object every time for every function such as attach and write. So the spelling should be correct. It's case sensitive, so just take care of the capital or small letters also.
So the code given by me on the QR code runs very well. Okay, you just have to change the values of the input and output. The output I have kept at 5. Right here. No, right here. This is the output, actuator. And the input I have kept A2. Right here. Right here. Fine. Now we'll run the simulation, start simulation. It will initialize the code, and if there is no bug, you will get a good green signal. Click on the code to minimize the code value, and now you can click on the flex sensor. Now just drag and drop, and you will see our servo is working. And that's how we simulate our robotic arm with our arm gesture glove, and in this way we can make our robotic. Yeah. Is it working?
Keep in mind this is case sensitive, right? Don't change anything like capital or small. Just keep it as it is. The input is written in the brackets, the A2, all that needs to be the way it is.
Is it working with anyone? Okay, fine. So we have used only one flex sensor, but if you can try, you can use it at home, and you will be able to make some better simulations like this. I've used 5 flex sensors. I'll start the simulation, and you can see all the servos, they are working according to it. Now imagine you have done the autonomy part on simulation, and now you can directly upload the same code on the Arduino or the microcontroller you are using, and now you just need the hardware to buy it. Assemble and just start. Autonomy not only gives you this visualization but also the confidence to deploy the model. Okay, now I would like to call Tejas for the surprise element of our workshop. I think everyone got the autonomy part. Is it the good?
Do you
Okay.
guys enjoy it?
I think many of you might not have laptop, but you can try. I think links are there on the WhatsApp group, so just try and explore through the components. Pages.
So you saw right how just that one part of the flex sensor and using the whole thing, just integrate it into something well planned, well designed, and you can make a whole club out of it. So see how all three divisions are important. Design to think about this structure, hardware to connect all this, and autonomy to code it. So this is how all three domains are linked. Next, so the PS. This is the problem statement. So we are starting the induction for in these two divisions, hardware and autonomy. For the problem statements, you can scan this, and we'll also. We have already shared the induction statement, so try to do it. We have mostly covered some of the PS problem statements details in our workshop. So if you have paid attention, then you might get most of the questions right. Try it. We have also added resources in it. So if you want to learn more about whatever there is in the problem statement, you can look into that also. Don't worry if you can't do any problem. Just attempt it. Do whatever you can. And if you get selected in the interviews, then we'll ask you based on what you have done. So there's no problem if you can't complete the whole problem statement. Just give it a try and do whatever you can. The main point of this is to learn. Whatever you learn from it, we will check that and not how much you are committed. Fine. Keep in mind the deadline, 7th September. So make sure you complete it before it. Right? So this is our whole team. Perfect. Then other members are here. Some of them are not present here, you do the first. Now, so this is one of our clubs actually, right? Called the Takeshi's Castle. This will be organized after the mid-sem break, right?
How many of you heard about Takeshi's Castle? What do you know about that? That TV show, right? Okay.
You never win the final.
What if we are also planning something great for you? Like you got the hint what exactly we do in robotics club. But there might be people who just want to get a feel of robotics without coming into the club. They just want this club for fun. So we are organizing this event named as Takeshi Castle, which is the flagship event of our club after your mid-sem break, in which you all will be there in a team of 5 to 6 people, and there will be a problem statement which we'll be releasing soon, and you all guys will make the robot according to that problem statement, and you'll just fight with each other using the bots. Do you find it interesting or not? एक्साइटमेंट दिख नहीं रहा है पर
कोको पे देखे हो ना तकलीफ कैसे सबने हाँ वैसे ही एग्जैक्ट कमेंट्री भी देखी मजा आएगी just wait for it, the event will be very great, so just be ready, learn whatever you can, and just be ready for the event. So thank you everyone, this was so we hope you got to learn everything from our workshop, and I hope to see you all in the inductions and in the interview. Yeah, this is our WhatsApp group, so you can join here for more updates. And did you enjoy it, everyone? यही तो था अरे तकलीफ कैसे तुम्हारे लिए इवेंट है नहीं मजा नहीं आया कोई नहीं इवेंट में मजा आएगा इवेंट में आना also follow our Instagram pages for our projects and
ये सरप्राइज है जिन लोगों ने अटेंडेंस जो लोग अभी प्रेजेंट है उनके लिए कुछ एक्स्ट्रा रिसोर्सेज होंगे फॉर इंडक्शन
एक फायदा है हाँ कर लो
ओके सो है ना ट्राई करना यहाँ पे कोई इम्पोस्टर ना बैठा ग्रुप में डाल दिया ठीक है
अगर अगर मुझे दिखा 480 एंट्री है उसमें हो गया एवरीवन स्कैन द क्यूआर कोड वेल सो दिस इज द वर्कशॉप थैंक यू इसका अगर कंपोनेंट देखते हैं तो यहाँ के देख सकते हैं
सबको अभी भागने की जल्दी है जल्दी जल्दी डिनर करना है कि आईपीसीसी की मीट में जाना है
गुड गुड अपनी ब्रांच के लिए था करो एंजॉय
अगर किसी को कुछ